So we are answering these questions now. We have this function that technically I meant to put 480 here, but so it makes it a little bit harder. When I plug into, if I'm not just looking at the table on the graph, which I can do that on my calculator and all of my information is right on my table, right there, then what I'm going to do is plug into 4 and 6. So in this case, I plug into everywhere there's a t, and I have negative 16 times 4 plus 416 plus 408. So that's negative 64 plus 416 plus 408. Okay, and that's what's showing up on the table as 760 feet. So this object is 700 feet in the air. I would just go ahead and grab the other ones. You're welcome to work it out like this if you wanted to, but I'm going to grab the other ones from the table. And so this one's at 984 feet. And this one at 6, when I plug it in, is at 1,080. Next are the physical aspects of the function. When you look at the graph, you see that you have this scenario. Now, don't forget that we actually are on a building, so we can draw this building here. Okay, so really bad building, but I'm not an artist, I'm just a math person. So I have that building, it's shooting up, and actually it's going up a little bit further up here, but the physical aspects are really the domain, and this domain are all the t values, or if you're looking at the x, y. I see that this is between 15 and 14. So it's between 14 and 15. When I found it on the calculator, and again, if I had used the number 480 here, it would have been it would have been just an integer. These two are integers, but this turns out to be a decimal here. This point is at the point 14.73, not something you'd just be able to pick up on your calculator. However, if you use the 0 function under calculate, go to calc. Calc is at second trace. And you can play around with that if you want to. Most of your examples on my math lab and what I'll be asking on the test are going to be with nice numbers, like if you have the 480. And you may want to try to find the physical aspects with this if it were negative 16t squared plus 208t plus 480. I almost wrote it wrong again. You'll see that the x-intercept here, or the t-intercept, is at 15, 0, if I'm remembering correctly. Let me just check it real quick. You can always fast forward if you need to. Yeah, it does hit right on an integer. So as far as the physical aspects go, what we want to do is just write out our values. So in this case, our physical aspects will be t is between 14.73 and 0. Okay, those are the physical aspects. Over here with the one I hope to have, this would be between 15 and 0. So either way, this one over here is definitely easier to find. The intercepts, well, you can see it from the graph here, but the y-intercept is the height of the building. And if we have the height of the building, it's kind of the starting point of the object. I'll just put the object start. No, I better put starting point. And the x-intercept, or in this case, the t-intercept, this is when the object hits the ground. So it tells us how long it takes before it hits the ground. I hope that helps. Thanks.